the update event as you would have in your C# model behavior script, right? So we're actually just polling for the input key from our player. So the second node is just polling for that. If we detect that the player is pressing the up arrow key, it flows to the next node, and the next node is a branch node, just checking if the player has pressed true or false. If it's true, we'll flow that output into a translate node, just to move
having a problem.
the z-axis, which is the forward axis, to push our car moving forward. Okay, so here in the Unity editor, we have the auto showroom template, and I've just built upon this to kind of showcase how we can use visual scripting. Over here in our car, we just have some simple scripts here to aid us. Nothing too fancy, just to change the color, the light of the car, and open and close the car doors. But we're not really looking into these yet. The main purpose we're here today is to use visual scripting to drive the movement of a car. So if I hit play right now, the car doesn't really have any logic to drive it to move anywhere. So we're going to create that from scratch right now. So I'll go ahead and add a component, and from here I'll look for the visual scripting category here. And you can see there are really only 3 components, so it makes it really simple to get started. So I'll add a script machine, which is the component that we just talked about earlier. And this script machine component comes also with the variables component that we mentioned earlier. So from here, because the project is going to be a relatively simple project, I'm going to just use a embedded source rather than a graph. So if I switch it to embedded, basically all that logic of that unit flow is going to be embedded inside this component itself on this game object. So let's go ahead and rename this to car controller so we know what it does, and then hit edit graph, which will prompt up this script graph editor. So I'll nicely just dock it down here to make it convenient for me, and you can zoom in and out on your script graph. But unfortunately, this is the maximum zoom I can move to. But so hopefully this appears nicely on the video stream as you're watching it. So you can see here there are 2 units, sometimes referred to as nodes interchangeably. They're interchangeably referred to as nodes and or units. So you can see there are 2 event callbacks here. That's the start node and the update node. For now, we don't really need the start node, so I can just go ahead and delete that. And on the event node here, what we're going to do is basically start polling for the user's input, right? So we're looking for the user to press the input get key up arrow. So I'll look for it by typing just get key. Alright, so I'll just pick the first one, get key, and here I can input the key that I want, so it'd be up arrow. And then from here we'll flow to a branch to check whether or not the player has pressed yes, whether or not the player has pressed the up arrow key or not. As you can see from the get key unit here, there is a outward flow with a purple dot, and this basically is just the Boolean output, right? If it's true, that means the player has pressed the up arrow key. If it's false, that means the player has not pressed the up arrow key, right? So first we'll flow to the node or unit that we want, which is the if branch unit, and you can see this also accepts an input, so they're the same color, so it tells you that they're the same data type, so you can just drag and attach that. So now we're feeding the Boolean information from our get key to our if unit, and if it's true, we'll do something. If it's false, we will do something else. But in this case, we just don't really need the car to react if we don't press anything. So here I'll just branch out true and translate my car. So we're looking to translate my car forward. So these are all the overloads that are available to you. I'm going to pick just the X, Y, Z and relative to. And what this does is it applies a translation to this object, which is the object that the component is attached to add a value of Z1 forward, and it'll be relative to itself. Y itself because and YZ is because you can see here it's aligned in a way and set up in a way that Z axis is pointing forward. So if I move it Z, it will move this direction. Okay, so script logic is done. I'll hit play. And the neat thing about visual scripting is you can see this pulse of logic flow that goes from the left to the right. So from the update flow, you can see this is the pulse going through to get key, and it actually stops at the if unit, right? Because it's still waiting for whether or not we press the up arrow key. Right now, it's the value that's flowing from the get key unit here is false because I'm not pressing anything. Therefore, you see there's no pulse going on the true branch. So if you press up, you'll start to see the pulse appearing, right? And it looks like it works, except the problem is that if I press up, the car just moves a little too fast. So we'll have to fix that. So what we need to do here is actually regulate the speed of the application frame rate using time.delta time. You can see at the setup at the bottom here, what we're doing is just multiplying the speed represented by the float 1 with the time.delta time, the get delta time unit. So what is delta time? The delta time is basically the interval in seconds between frames. So imagine 1 second here in game. Typically, most games aim for 60 frames per second. So in our application right now, we can think of it as 1 second is 60 frames. If you divide 1 second by 60 frames, what you're getting is basically the interval between frames in seconds. So here we're getting 0.0167 seconds per frame. But why should you multiply by delta time? Like if you consider 1 second is 60 frames, and 1 unit in Unity is 1 meter. Within 60 frames, which is 1 second, you're basically traveling at 60 meters per second, which is an insane speed in real life. So you'll have to regulate that in case there's any like a sudden spike or drop in frame rates, because not every machine works the same and not every machine runs at the same frame rate, so you have to regulate it to your target frame rate for your application. So I'm just going to go back over here and try to regulate that, and what we're going to do is really just bring in our time.delta time, get delta time unit, and I'll multiply that with a float, right? So just bring in a float literal, set as 1, and hit multiply. Okay, multiply, plug that into A and B, move it to the side, and input that into Z. So now hit play, and you can see if I press up, our car moves at a slower, much more predictable constant speed, right? So it's moving at basically 1 meter per second at this speed. Okay, and then if you want to increase it faster, we can push up the float and they'll move our car slightly faster. So next we're going to look at how we can add variables into our script machine. Now we can basically move our car forward, but all that the speed setting is kind of embedded within the script machine itself. It'd be great if you can expose it in Inspector. That way we as developers or designers will be able to change the values easily without having to tinker with the script graph itself. So variables here are are represented in a component, and they keep track of any data that you want. And you can store them in the graph, the objects level, the scene level, app level, or saved for other sessions. If you save it in the graph, it comes embedded in that graph asset. On an object, it'll be embedded in just that component with along with that game object. On the scene level, it's basically a variable that's available to all your classes and all your script machines in that scene. On the app level, it's basically a static variable, which means that it's just available in that session until your game restarts. And for the saved level, basically is your player prefs. That's what you use for persistent data. If you want to save your some data for that to persist between game sessions, things like your volume settings, for example. Alright, so I'm going to show you how to replace that float value with a float variable declared in the graph. So back here in Unity, you can see that our float value here is the one providing our speed, and we want to change that to be a variable that we can tweak outside here in the inspector. So what I'm going to do is actually add a new variable inside our blackboard, and what I want to show you here is that on the object level, this particular field here is directly related to the component variable, the variable component that we have on our inspector. So if I were to add like a variable called speed over here and add that, you can see that it also directly adds it here, because these two are related. Now if I change this to, because we're expecting a float value, I'm going to change this to a float value and set its default value to 1. And then what I can do here is now just drag and drop this into the script graph and delete that float value here to replace it. And I'll just plug this output into the multiply. And now what I can do is hit play. And if I'm not happy with the forward speed that I'm having here, I can always change this to something higher, like 11. And you can see now my car moves a little bit faster. So next what we're going to do is actually move the car in reverse, and that's actually easy enough. All we have to do is invert the speed to go backwards. And how we do that is really just multiply the existing speed value with a negative number. That'll just move it in the opposite direction. So let's get to it. So over here, what I'm going to do is actually just duplicate this setup over here, because I'm doing basically the exact same thing, except that I'm checking for a negative value. And you can see here in the original graph, I have this flow that continues on, that I can continue from the end of it and check for like further logics beyond just the translate forward. But I shouldn't be continuing from the end portion here, because this is when I actually move forward. Like if I'm not moving forward, I'm obviously moving backwards or just standing still. So I should check from the if statement branch here. Like if I am not moving forward, which is false, then I should detect for other events, right? So I'm continuing from this false flow over here. So instead of going the up direction, I'm going to go the opposite direction, and that's the down arrow key. And I need to now also invert the direction here. So all I have to do is really hit multiply, attach these values over here, and then add another float value. And this is just going to be a -1. Touch it here and hit play. And now I should be able to go forward and as well as backwards. So the next thing we're going to talk about is super units. So as you can see, our graph has grown to quite a complex setup, and it can only become more complex from here on out. And if you come back a week from now, it'd be hard to kind of understand where you left off or what you did here in this graph. Right? You usually have to go through your units one by one to kind of understand the flow of logic. But there's a way to make this simpler and easier to read and faster to get back into the flow, so to say. So if you look at super units, it's really just a way to create a custom unit to encapsulate a bunch of logic, or to group a bunch of instructions so that it becomes just one simple unit that you can just read and understand really, really quickly. So fortunately, we have a great example here where we have this translation node get fed with a normalized speed, right? So you're pumping in velocity into your translation, and it happens the same thing again over here where we're translating, but just with a slight variation where we are reversing the speed or the velocity here. Right, so what we can do is just right click on the script graph and add a unit, and I'll just go ahead and search for a thing called super unit. Right, so with this super unit, what I'm going to do is actually, instead of having it be embedded in just this graph, I'm going to change it to a graph asset. And what this allows me to do is save it as an asset within my project. So I can call this, because our logic here is really just moving our car in the z-axis, I can change this to move in z-axis. All right, and I'll just double click into this, and what this allows me to do, because it's an asset, I can reuse this in a different script graph on a different object, or I can even reuse this in a new project or future projects in my future games in my studio, or share it with anyone. So what I'm going to do is just right click into this, and you can see there's just a simple input and output node, and what I can do is define the input and output flow too. Right, so I can just add a new trigger input, just simply type in, and same for the output. If I want one, I can just type in an out. So these are optional, but if you go back into your main script graph, you'll be able to see that now my super unit has an in and out. Right, and yeah, you can treat super units as basically a sub-layer of your main script graph. Right, so it's really just a script graph within another script graph. Now what I need to do here is actually input in the speed, as well as account for the way this can vary by inverting the speed. Right, so let's go back into my super unit, and I can define what I want to accept as my data input. So I'll just hit plus, so I just add a new data input here. And because we're expecting a speed and that's a float, I'll just add a float called speed over here, and another one for varying the direction. So I can just add another boolean to say this is for forward maybe. Right, and add a default value, so maybe this is true, the beginning, so that it's moving forward by default. So now that I have these data inputs, all I have to do is just go back into my script graph and then pull these existing logic into the move in z-axis. So I'll just double click into it, paste that in, and now all we have to do is just vary this by going into an if node. Right, so just do if this is true, means we're going forward, and then we will process this logic down here, which is the forward direction. And then what I'm going to do is, we also have this speed input, so I'm going to feed this into the multiply, right, instead of getting it from the object variable, because we're planning to also maybe use this super unit in different script graphs, so we shouldn't be dependent on the object right here. So I'll just delete this portion. So same thing for our reverse. I'll go ahead and select this part over here along with the translate, cut that out, go into our super unit and paste it as the second part of our script here. right? If this is false, then we'll process this logic instead and also feed it its speed down here, right? So all we're doing is inverting that speed over there. Okay, let's just arrange this as best as we can. So that's true, and this is false for reverse. Okay, and if we need to, we can output from here if we want to continue the flow of logic in however we want. Okay, it's a little bit messy here, but I'm just going to move on for the sake of the webinar. And what you have here is really the super unit now, so we can flow this into there. And likewise for our reverse, if we press the down arrow key, we would flow the other way around. So because this is now a graph asset, it's part of your entire visual scripting system. Now I can just type in move in z-axis and they'll just give me a new super unit that I can feed into. So if this is true, if I press the down arrow key, I can go in reverse. Right? The one thing that we just need to feed into this now is the speed variable, and that can be obtained from our blackboard, which is basically from our variable component. So I'll just drag this over here, get our speed and feed it to that, duplicate that and feed it into this as well. Okay, so let's see how this works. So I'm going to hit play, go into play mode and press forward. You can see that, oh, looks like I've made a mistake here. Ah, yes, this moving z-axis here should be positive. I must have disabled that by mistake, so I'll just enable that. Right, press play and press up. You'll see that I'm moving forward, and if I press down, it moves backwards. Right, so it's basically just flowing into a sub layer to the super unit. If I click into the super unit, you can see this is also flowing, right? And if I want to further group this and make it more organized, I can do so in the super unit itself. So let's say I could use actually hold control on my keyboard and left mouse button drag to actually group this bunch of nodes to say this is the forward logic, and the bottom portion here will just mash them together nicely, group them like so. Again, it's control and left mouse drag. We'll call this the reverse logic. All right, and then this also makes it easier to read inside your super unit as well. And the cool thing is they also move together, so it makes it easy for you to move things around. And we can take this concept even further by simplifying what we have in our main script graph. As you can see, things are still kind of not too complicated, but it still has some complexity that we can still simplify. For example, we have this check where we are constantly checking for the up arrow and the down arrow, and we can make a simple super unit to make this even more readable. So what I can do is just add a new super unit right now. And for this super unit, unlike the one that we built earlier, I'm not going to create a graph asset because this particular super unit is very specific to just this graph itself. So I'm going to keep it as embed and jump into the edit graph. And what I'm going to do here is, because in this super unit, we're going to branch out to check if we are pressing the up arrow or the down arrow key. All right, so in here, we actually only need just one trigger input. So I'll just add one in, but we'll have two outputs because we need to check whether we're pressing up arrow or pressing down arrow. So I'll just label this as pressed up arrow and also pressed down arrow for the other one. Okay, it's just as simple as that. And I'm going to go back to my main script graph just to copy the nodes that I need and paste it in here. So the flow of logic is going to be very simple. When it flows in, we're going to check if we press the up arrow first. If it's a yes, then we'll flow this to press up arrow true. And if it's false, we'll flow to check if the down arrow is pressed. If it's pressed, then we'll output press down arrow. If it's false, we can always output to a third output flow here, or you can just leave it as is and it just does nothing. So I'll go back to my main script graph, and we can simplify this greatly by just removing all of these if statement checks. All right, flow from our update into the super unit, and then flow pressed up arrow into the move in z-axis, and likewise for reverse. And now can pull them close together and can see it's much simpler now. We only have 3 nodes, and for the get variable, because they're so close together, I can even feed the same get variable and reuse it for 2 other nodes here. So this is pretty simple to read now. It's guaranteed to be readable in 1 or 2 seconds. You can see in this super unit, if I press the up arrow, then we move in the z-axis forward. And likewise, if I press the down arrow, we move in the z-axis backwards, right? So it's pretty much easily human readable, and you can get back into the flow of things in a week or a month's time from now. So let's see if this works. I'll press play again and move forward. It still works, it flows, and still works backwards. Great. Next, we're going to look at how we can set up our script machine to run custom C# scripts. So in this example, we're going to run a script from our script.flow machine to actually change the color of our car. Right? So let's look at what we have here. If we look at our car color script, you can see that there are a couple of public methods that we can access. So as long as these methods are public, you can actually use it to to run the methods that are in there. So in here we have a set next color that we can use. So the way we can access that is really simple. So I'll just go into my script machine again, and we could just process this whole logic in another update unit here. All right, we'll just flow out, and how you find the script that's attached to your game object is, because it is attached to the game object, you can see that it's, the first thing that we have in this search list here is the game object itself. If you click on that, you can actually access all the components that's attached to it. So one of those components is that script called car color. So if you just click on that, you can see these are all the available methods that are made public to you. So the one that we're looking at or looking for is the set next color. Right, but before that, you probably want to check for an input key. So say get key again, and we'll check for get key C for color. And again, we want to check if this was pressed. I'll pass in that boolean there. If it's true, then we will run that script. Car color, set next color. Okay, and let's head back here, press play, and just hit C. You can see the car color changes thanks to this script over here. And lastly, I want to show you guys state machines and custom events. A state machine basically allows you to set your script machines to only run in specific states, and custom events allow your script machines or your unit flows to only react to certain changes elsewhere. All right, so what we have here is going to be, we're going to have a UI on screen that's basically just your title screen, and the state machine is going to control whether you're in the title screen mode or in play mode. And the way we're going to switch between the title screen and play mode is through a custom event that will be triggered elsewhere. Alright, so let's look at how this is done. So first of all, we have this scene here. It's just basically the two parts of the canvas. We have our play mode that can toggle on and off by just turning on and off the game object. And then we also have the title screen. Right, so I'll just leave these two on by default, but we have to turn off either one depending on which state they're on. So to get started, what I have to do is actually, instead of adding a script machine, this time we're adding a state machine. Alright, so I'm just going to keep this as an embedded script machine or state graph. I'll just hit edit to go into the state graph editor, and what we have here is just one state to start off with, and I'm going to rename this to title screen. And I'll duplicate this to be another state that we will toggle in between, and this is going to be the play mode. Okay, now I'm going to right click on it and transition it from title screen to play mode, and vice versa, allow transition from play mode to the title screen. Alright, so now I'll go into my title screen, and you can see here there are 3 different units, event units here. One is the enter state, the update that we're familiar with, and then exit state. The enter and exit state basically runs once, either when you enter or exit the state. So for this instance, we just want to turn on the title screen mode when we're in this title state, and turn off play mode when we enter it. So for this case, we're going to use the simplest unit of all, which is the set active unit. Right, so what this basically does is just turn the game object on and off. It's as simple as that. So when we enter this state, which is the title mode state, we want to turn on our title screen mode game object. So I'll just feed this over here. Okay, this is going to be on, and then we're going to have one more that's off, and this is going to be the play mode. Right, the play mode game object. So I'll feed it into this as well. So we're going to repeat this also in the play mode, but invert all the values. So I'll just exit out into the scene controller again and go into play mode instead. Paste it over here. Same thing. We're going to configure our enter state to go through this flow and just invert those values. Next, we want to set a way for this to be triggered. Alright, so for our play mode here, we're gonna allow ourselves to exit back into the title screen if we press the escape key. So just do a get key again. Alright, and then looks for the escape key. And we'll check if this is true. Pass that boolean over, and if this is true, we will trigger a custom event. Right, trigger a custom event. We'll call this stop game. Okay, likewise, we're gonna do the same thing but inside the title screen. Same thing on the update. Paste it right here. This is only if we press maybe the space bar. So if we press the space bar, if it's true, then we'll start the game. Okay, so we just need to remember the name of the custom event because we're going to use this to trigger the transitions. Right, so I'll copy this, go back to my scene controller, and you can see these are the conditions for your transitions. Right, for title screen to transition into play, we'll actually have to add a condition over here. So all I have to do is just double click into this. You can see this only has an output flow. So I'm going to define the transition as a trigger custom let's see, it should be custom trigger, custom event. Custom event on start game will trigger this to happen. Same thing, I'm going to copy this and go back into the other condition. This will be stop game. And so transition, trigger the transition here. And the next thing I want to do is also determine which one of these should be the starting state. Right, I'm going to select the title screen, right click, toggle start. Oh, it should be this one to be start, and then toggle this to off, so you can see the green one should be active. So now if I hit play, right, it should be title screen first. You can see this is highlighted blue, and if I press spacebar, you can see there's a flow that flows, there's a pulse that flows into play. If I press escape right now, it'll go back into the title screen. And as a bonus, as you can see over here on our title screen, or actually on our play mode screen, there is a toggle colors UI button. So we can actually add that into a specific state as well. So since we have the play mode state over here, I can actually just drag in the button in here and look for an on click event, on click, or just type on click there. On click, on button click event, right? So if we press that button, this event will actually fire, and what we can do is pass this to the change color script. So I'll just drag in the car again, right? Look for the script that we want. That should be under car color, set next color, and just make sure that it references the right car over there. Connect the flow, and when you hit play, that button functionality should now work. So I'll just press spacebar, enter into play mode, and I can toggle the car color just using this on-screen UI. And that is visual scripting in a nutshell. And here are some resources to help you in your learning journey. And as always, the learn.unity.com portal is the best place for you to get started on anything in Unity. So if there's a new feature that you want to take a look into, the Learn portal is always there. If you want to learn more about visual scripting, there's an introduction course to help you through it, and there are more advanced topics for you to explore as well. And from here, we've pretty much learned some of the really core basics of visual scripting, right? We've looked at script machines, we've looked at super units and encapsulating or grouping a set of instructions. We looked at running C# scripts, custom scripts that maybe someone else has built. We've also looked at setting up custom events and have that custom event drive your state machines. And from here, you can really build anything from industrial simulations to full-fledged video games. And with that, we're going to open the webinar to questions.
Okay, I think we probably serviced most of those questions, Sean, it looks like, during the webinar. We'll wait maybe a minute or so to see if there's any more. The survey form has been posted in the chat window. Please go in, please help us to gather some feedback on the quality of the sessions we deliver. And we're giving away a swag pack for one lucky person who's joined us today. Last week's winner has contacted us back with their address, so they will soon get that prize pack. And just to, while we have everyone in the room, it'd be great if you could go to the chat window and let us know if you are a beginner or if you have just recently started watching our sessions. We're thinking of doing a boot camp in February, where we will cover the main features and have a little bit of tech support potentially, and the opportunity for you to share your projects throughout the course of February. Just something we're thinking about and planning, but if you are at the beginning of your cycle and you think that would be something you're interested in, please let us know. Q&A.
Yeah, we have time to take some questions. So we have a question from Jeremy Terrier. Is there a way to reroute connections to keep the graph tidy, similar to reroute node in UE blueprints? So unfortunately, I am not familiar with UE or in real, but you can keep the graph tidy by having super units or group them with your control and left click just to group and move them around. For another question regarding teaching visual scripting in detail, I guess in detail we'd have to have more specific topics to cover. But this is a good overview for you to get started. If you need more specific topics, you can always hop on to Learn, the Learn portal to check it out. And yes, for you're not limited to update. You can also do fixed update and something cool.
Okay, is that it for the Q&A, Sean? Excellent.
Yeah, I think that's it for the Q&A. Any more questions?
So if you have any further questions you think of afterwards, you can always contact us on the email that is in the chat window where our social media links are, the events SAPAC email address, and we can forward that to Sean to answer. Also, stay tuned for our content coming up later this month for the rest of our webinar series. We'll take a bit of a break mid-December and rejoin you late January, early February for next year's series, but we still have a few more sessions to cover this year. And just a reminder of those sessions. Next week, we've got Take Your Games to alternate app stores using our UDP platform that enables you to publish across many other platforms. Of course, there's not just Apple and iOS. When you're talking about audiences in Asia, there's many, many different platforms. And then we have a few other sessions which you can see there on screen, taking us up to 10th of December. Please register for each one of these separately. You would have got the email. If you didn't get the email and you've registered online, look out for our weekly posting early in the week for the session that is occurring on Friday. And happy weekend to everybody. Stay safe. See you next week.